1.8 Other types of inequalities. The last section of chapter 1. Look how far you've come already just with chapter 1. I'm so proud of you. Okay, we've solved an equation before. Now we're just solving and graphing. Now again, we only have one variable there. So it is still on a number line that we're going to be solving and graphing. Just like how we've solved before with the x squared, we have to solve by factoring. You could use the quadratic formula if you really had to, but I would highly suggest just solve by factoring. So the first thing we do is we factor. What numbers multiply to get negative 6? Add together to get negative 1 would be a negative 3 and a positive 2. So this is what we have. If this was equal to 0, at this point you should be able to get 3 and 2. Those are important numbers. 3, and negative 2. So now we're going to graph. Now, when we have a quadratic, it's a little bit different. Our points of interest are at negative 2 and at 3. So what we're going to do is actually we're going to pick a point on each one of these to test. Now, there's two ways of doing this. You could pick a point, like 0 is the easiest one here, because if I plug 0 into this, this is easy to do mental math. But here, maybe pick negative 4. Here, maybe would pick 5. You could definitely do that. You can also plug it into your graphing calculator. So I put it into my y equals. I'm going to put it right here. Sorry for the glare. I go second graph so I can get to the table. So I'm looking for it at negative 2. Here's my negative 2. That's a point of interest. If I look at numbers smaller than that, I'm looking to see, does this make sense? If I put a number smaller than negative 2, like if I put negative 4 in, does this make this equation true? If I put negative 4 in, I get 14 out. So is 14, that's what I would get right here, less than 0? No, 14 is not less than 0. Okay, so now we're going to pick something in the middle. So negative 2, let's plug in 0. If I plug 0 in, I get a negative 6 out. If I plug negative 6, is negative 6 less than 0? Yes, this section is true. Now, if I can look at 3, well, something larger than 3, if I plug 6 in, this right here is equal to 24. So is 24 less than 0? No. So that means these two sections are false. This is the only one that gave me a true statement. So when I look at this, they're going to be parentheses because this only gave me the true statement and it would be shading in between. I want you to try to pause the video and do B by yourself. So closed, so it's going to be a bracket. Now my true statements are on the outside. So I'm going to have a bracket at negative 4 shooting to the left and a bracket at 5 shooting to the right. Everything in between was a false statement. It does not include that. So when we get into these problems, it's all the different types of factoring that we already have gone through in this whole chapter, all the review. So first thing, I want to get this equal to 0. So I have my 2x to the third minus 3x squared minus 32x minus 48 is greater than 0. Well, because it's a cubic, I'm going to factor by grouping. So I want you to pause the video and try to factor completely. When you factor by, you should have got an x squared minus 16, and then that broke up to x plus 4x minus 4. So this is what we have. So now if we solve this, we have 3 different zeros. X would be equal to a positive 3/2, a negative 4, and a positive 4. So when I look at my number line, I have to have all 3 of those spots. Negative 4 is the smallest. Then I have my 3/2, and then my positive 4. All of them are going to be parentheses because it's not included. So again, for all of these, you can mental math doing this just for the sake of time. I'm plugging the original equation into my y equals. I'm going to my table. I'm looking to see where is this equation, because y is all the outputs that I have. Where is this equation greater than 0? So first I'm looking at negative 4. Well, that is not greater than 0. We're looking between, I'm sorry, this should have been a minus, and this should have been a plus right here. So this is still factored correctly. Sorry, I need to change that. This is a minus, and this should be a plus. Sorry about that. So now that looks better. So if I look at anything at negative 5, so less than negative 4, is that greater than 0? Is not. But in between negative 4 and 3/2, this is all greater than 0. So 3/2 we can't see there. But if I look in between 3/2 and 4, so 2 is in between 3/2 and 4, that doesn't work. So this is a no. So this was a false, true, false, and then anything greater than 4 that is greater than 0, true. So I go back to the actual graph then. I have a parentheses, because these are all parentheses. There's a parentheses in between -4 and 3/2. That's included. This was a false section, and then from 4 and on. So this is what that graph would look like. Try to do B by yourself. So this is what your graph should look like. One thing, what if I ask you to write your answer in interval notation? So once I have the graph, and actually if I didn't answer the graph, you should still be able to write this in interval notation if you know the section. So if I'm writing this in interval notation, it's saying that I have a solution here in between -4, it's not included, and 3/2. And then I also have a solution. So this right here is a union with 4 to infinity. So this is writing that in interval notation. So here when I'm looking at this, I'm reading like a book, left to right. So this is going from a negative infinity. Whenever we write an infinity, it's always parentheses because it goes on for, and then this is still a parenthesis because it's not included, union 2 to infinity. So those are two written in interval notation. You should try to do C and D by yourself, but we'll go over those in class. So now we have A, B, C, and D. So they don't look much different at all from what we already did. So I want you to pause the video and try to do A and B. But actually do A, B, and C, D as far as you possibly can. So factor, try to get your intervals and see why these might be in their own example. So these are all special cases. Maybe you didn't even pause the video at all. You were like, oh, nope, I'm not going to try to use my brain. So a couple of things with special cases. First, when I look at this, you can always graph these in your graphing calculator. You can push the graph button. You can see what it looks like, and you'll be able to see that this is always above the 0. It's greater than 0. So there's no time that this graph, because when we're working with a quadratic, we have that parabola. So if I look at this graph, it says, when is this graph going to be greater than 0? Here's that 0 line. Sorry for the glare. Here's that 0 line right there. When is it going to be greater than 0? Always. It's always greater than 0. Now this one is a little bit same thing. It's saying, when is this equation going to be less than or equal to 0? So again, now we're working with less than or equal. Well, it's never going to be less than because it's always above, or equal to 0. It's on the 0 right there. So there's only one number. Only when this is equal to 1, only when x is 1, is it equal to 0. That's the same type of thing here. It's the same type of thing here, except this is flip-flop. When will it be less than 0? Well, that's an empty set. It's an empty set because it will never be less than 0. So it's kind of like the opposite of the A. And this last one, when will it be greater than 0? This equation is always greater than 0, but it's equal to 0 at 2. Because 2 is not in that set, it would look like this. Again, we will be working with these specialty types, but that is just a brief thing that you can always check your graphing calculator to help you. And our last example, first thing we want to do is set this equal to 0, so we're going to have to subtract the 3. We also need to have common denominators. So I'm going to subtract the 3 here. So that's x minus 5. My common denominator will be x minus 5 because I want to write this as one fraction. Okay. So again, I subtracted the 3. I did 2 steps in that. Sorry, I did 2 steps in that scenario. I subtracted the 3. That's the subtract 3. And I also have the common denominator. So when I write this as one fraction, this x minus 5 is on bottom. I personally, I've said this before in a different video, but whenever there's subtraction, I go plus a minus. So when I distribute this right here, this becomes a negative 3x, and this becomes a positive 15. Okay, I subtracted the 3, so I made that plus a negative. Distribute the negative 3 in, that becomes a negative 3x, positive 15. So I can combine my like terms. Negative 3x plus 2x will give me a negative x. 15 minus 7 will give me a positive 8. Okay, this is what I have so far. Now everything I did right here is basic algebra. So if you struggle with basic algebra stuff, you have to come in and see me. So now when I'm dealing with a fraction, you always have to think what number can x not be? Because when I'm solving this and graphing it, the number that x for sure could not be is I cannot divide by 0. You can't say I have 20 things, I'm going to divide it up 0 ways. No, that's impossible. So already I know, because of this denominator, that x, so I'm going to write myself a little reference, x cannot equal 5. Because if x was equal to 5, that would not be good. That would give me 0 right there. When I'm looking at 0, when I'm solving an equation just for 0, I'm really just focusing on the top portion. If I just look at the top portion, the numerator, and I do this and say, okay, if that was equal to 0, what would this be? So I would subtract the 8, and then I would divide by -1. It would be an 8. So these are our points. These are our points that we're going to test in between. So when I'm graphing this, I have 5 and I have 8. I know for sure 5 is not included. So again, I'm going to go to my handy dandy graphing calculator. I already have it in my y equals. I just use a division bar, just like that. I'm going to put it over here. I'm going to go to my table. I'm looking to see when is this equation when is this equation less than 0? Because this is my equation. When is it less than 0? So first I'm looking below 5. So here's my 5, and it should be an error. Below 5, is this less than 0? It is. So I already know that from here, not including the 5, this works because that portion is less than 0. Now I'm looking in between my 5 and 8. Does in between 5 and 8 work? Because that could happen. In between 5 and 8, is this less than 0? No, it is not. So I'm not going to shade in less than 0. Above 8, is that less than 0? It sure is. So again, this right here is going to be a bracket though. So why is this one a bracket and why is the other one a parenthesis? Remember, x cannot be equal to 5. So that's why we have this parenthesis at 5. It cannot be equal to 5. It can be equal to 8 because of this line right here. It says or equals to. So that is why it's or equals to 8. So if I write this in my interval notation, it would look like this. From negative infinity, I need to work on my infinities, to 5, union, bracket at 8, because it can be equal to 8, to infinity and beyond. I want you to pause the video and try to do B by yourself. If you want to check over my work, you have to combine those two fractions. Remember, x cannot be equal to 3 because of this denominator. We set the top equal to 0, get x to 11/4. Now, this is where it's a little bit tricky. 11/4 is 2.75. So we cannot check this section on our calculator. What we would have to do, and what I personally did, is I took 2.8. I know 2.8 is in between these. I did the top. I put 2.4 times 2.8 minus 11, and then divided that by 2.8 minus 3. So I plugged it in for my x value at -1. -1 is not greater than or equal to 0. So that's why that's a false statement. So this is what it looks like. And bing, bada, boom. That's all I got for you today. Have a grand and a wonderful day.